Hey, today we're gonna use a debugger on Windows to modify how the EA Origin app works so that it doesn't show us the annoying you must install the EA app window because don't want to upgrade maybe. So if I start Origin, I want to show you what happens. Get little menus here and menu stop working. You get this window and you can do nothing. So we're gonna quit Origin, start the x32 version of x64 debugger because Origin is a 32 bits program. I'm gonna click on the little open dialog and open Origin in program files. That's gonna load the program, and I'm just gonna go through what's important if you've never done this before. It's my second time using this debugger, so I also don't know all the options in it, and if there's better ways to find some things. But the idea here is to try to find out how the Origin program works. So when you launch it, you can see there's like something that looks like a web interface, so you can kind of guess a little bit. And if you look at DLLs, there's Qt5 and Qt5 web libraries. That's a framework to make applications. Obviously, having a web renderer in there, you can see the Origin application is pretty small at 3 megs, but it has a Origin client DLL at 40 megs, whereas it's probably most of the EA code in this case. And so you have already a little bit of an idea of what it's doing just by looking at it. So what is that application? And we're stopping at the entry point. It says pause, that means the execution of the application is paused. You have registers with pointers to memory on the side, like EAX and so on. And then again, this is where we're in the code. There's a bunch of tabs, memory map, breakpoints, symbols, and so on that we're going to use to kind of figure out what this program does and see what we modify where. So I guess to start with, we've seen menus gets disabled, so it'd be nice to re-enable them. And if we go here, we can see the library loaded by the application. You can see it's not everything yet because it's missing the Origin client and the Qt5 DLL. So I'm just going to run and let it run a little bit and let it stop. If you have the default setup on this debugger, it will basically run to user code if you want by just going to debug, run to user code, and then stop. And then you can go look at if libraries are loaded. Click on them, like origin client.dll, so what I'm looking for in this case, and see the exported function calls and look for things like update or log or things that you may guess, or menus in this case. And there's a bunch of menu functions, and eventually going through them, I find there is some kind of disable all client menus. So you can double click on it and it will put you into space in memory where this function is executed. It's not executed yet, right? We've paused the program way before, but you can look at it and get a bit of an idea of what it's doing. You can see it's calling disable client menu, disable system tray menu, and then returns, means the function ends. So let's see how this function is called. So you can click at the start of the function. This is where it should put you, but just if you want to verify it, it's usually a return function just before. Maybe some int3 that the interrupt this debugger uses to show you it's separate, and some filler effectively in the address space. You can right click at the start of the function, go to find reference to selected address, and then we'll find what points to that address in the code. So what's calling the function. Double click on it and it says call, like function call. You can see it's calling that function, doing a few things, and then return. Okay, so we kind of know now where we think the menus are disabled. If I keep scrolling around here, you can see it's doing a lot of setting related things, like get your frame per second display settings, how the opacity of it, like do you want push to talk and things like this. And if you keep going around, you'll find a function. So one is interesting called restricted access mode. I don't know what restricted access mode actually does. I thought it might have been the thing that restricts everything. Put this dialog up. It's not. It's something else. I don't know what it is. But if you keep scrolling, you'll eventually find something about migration of settings. So you can see like write settings and so on. And there's one here that's called find user migration. So all of those things happen before the menu are disabled. And that's important because I'm looking for what is the thing that tells Origin to disable the menu. So I could just tell it ignore that, and then the dialog also won't show up in theory. Because that's how I expect the program works. And if you keep scrolling around until you find the function return, you'll find that this find user migration is actually the most interesting one. And if you click on it, you can see what it does as well. And so I double clicked on it, so it opens or it goes to the address where the function runs and see a bit what it does. And you can see it's pushing something about disabling the migration. If I scroll through, it's looking at time and set migrations to enabled eventually, then shows a DLG, so dialog for sunsetting something. You're like, oh, sunsetting Origin maybe. Show takeover, and then show takeover for EA app installed after. Like, oh, that must be the takeover screen. It effectively is the takeover screen. On a bunch of stuff like this. So like at that point, it's when I knew, okay, that's the function I'm looking for. This is looking for the settings. It's looking at a time window at which it should start to tell my user, hey, no more choice. You're going to EA app. I'm like, what if I just change the value that it returns, or just maybe even just keep the function? If the rest of the program doesn't need it, then the default will be migrations not enabled, and then I'm fine, right? And effectively, you can do that fairly easily, so that's pretty nice. So now we know also the name of the function. So if you want to go back, you can also just, so we know it's like this find user migration. You can go back to your symbols, type find user migration, so it finds directly. It's a bit faster. You can double click on it, puts you back at the start of this function. Again, this time I'm in the function itself. So if I want to go back to what it's calling it, I have to go again to find reference to selected address like I did for the menus. Double click and I'm back at the top level. When you're running the program, this debugger has a cool thing. If you hit G, it shows you a little square like this that shows you the function call in the tree. It's not always super useful, but if you play with it, it can be interesting sometimes just to show you where it would go. Anyways, we're back here, the things that call this function. And usually we have two choices. One is we can erase the function by replacing by mnemonic, that's the little calls here, or move and so on. That says nope. That stands for no operation. It just tells the CPU, hey, do nothing. And if you right click on this, due to binary, you can do fill with nopes. This will effectively do that. Sometimes it's unexpected if the function is required for some other things. Usually what also happens is a function will change some register value somewhere, and there's going to be some kind of test, like here it says test, and then a jump. And these debugger jumps are highlighted in red, and it means jump to somewhere else in the code and skip some instructions. Usually you're going to see something like this, so like call, blah, 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 test, jump. And this one means if this is equal, then it's going to execute some stuff. So if not equal, but if it's equal, it's going to jump to the next function call. So we can kind of guess here that it's probably the thing that will actually show the dialog. So we could choose to either like just tell it don't read all those things, or go in the function and return the right value for, hey, I don't want migration, or just override the jump. It's kind of up to you. Sometimes one works better than the other. Sometimes also there's multiple jumps, and you kind of have to see like which of those jumps matter. So if I click on the next jump here, GMP, so this one just jump, you can see there's an arrow that shows it goes way further, and in the middle I see like restore default key. So I'm like, this jump's probably not the one I'm looking for. It's probably unrelated. It's probably this one right here. So if you select it and you hit space, or you right click and you go to assemble, it will open a little code editor where you can change the instruction. And so we're saying jump if equal, or JE. You can change it for jump if not equal, or JNE. So do the opposite effectively. And then do OK, and then close the assembly window, and now it says JNE. And then you can try to see if this works. So just hit run. And if you run into like exception, you can do Shift F9, just tell it, hey, stop pausing, just run. And every time it pauses, do it again. You can set that up in the debugger setup as well, so it doesn't bother you as much. Anyway, now it's running. wait for things to load, see what happens, and oh, this time I see my icons and my menus, and effectively everything works. So we modify what the program does, and you can now use Origin again. So what's next? Well, you probably want to save your work, so you can do right click in the CPU window, go on patches, and then it will tell you, hey, you made a patch to this program, you change one instruction at this address. You can save it by going to export. It's just going to save your change, and you can patch that back in manually with the debugger. You can do patch file, which is going to create a new file. That's what I'm going to do here. And what we're modifying in this case, if we looked at the module we were in, like in the window, it says module anti-DLL right now. But if we're going back, it should say origin client.dll, because that's what the code is. So I know that my patch is going to be for origin client.dll. I'm just going to call it that and save it on my desktop. That's going to say applied. On create it, you can verify by looking at the properties and looking at the size. For example, I'm like, this is pretty much the same size as the DLL that we looked at. So that seems about right. So now I'm going to close this. Origin works, right, but it's in the debugger, so that's not very convenient. I'm just going to kill it with the stop button. Go to my origin directory. I'm going to move away my original DLL, call it dot original or something like this, so you don't lose it, just in case. I'm going to move the new one patched here, and I'm going to try to start origin. Okay, so now you have a new error dialog. You're like, why do I get this now and I didn't get it before and it just worked? Well, most of the time those programs will have a thing to see if files have been modified or damaged so that it can restore them. And those files can also be signed, by the way, and the signature is going to be incorrect now because I modified it, right? If I do properties, you can see detailed signatures, there's an EA signature. This cannot match. I changed the file, right? It's going to fail. So we need to also modify Origin.exe itself. So we're going to debug it again. We're going to want to remove that check so that it loads DLL. And the reason it didn't trigger before is because the DLL was already loaded. We modified it as the way it's functioning in memory. So it already checked the signature at that point. Okay, so we're back in the debugger. We have a modify library now on the disk, so we don't need to patch it in. It's already patched on disk. We just need to get rid of this dialog effectively. So what you can do is just run the program first, just to see what happens. So we get this little dialog, and if I stop with pause button, I should be able to find something about that dialog somewhere in the program. So here we stop in the middle of the program somewhere. No idea what's going on here. It's a bunch of weights, it looks like, right? What we can do though is, so one is we can still do the symbol thing like we did before, click on the origin.exe this time because we're guessing we haven't even loaded the DLL, and see a little bit of what it has. There's a bunch of functions that are standard functions from Windows. One of them is probably actually message box, right? Because we see a message box of some kind, like this user32 message box probably, which you can click on, see where it's actually sent, and do the same we've done before. Like look for the address, see if it's called, and see, oh, it's not called, so maybe I don't care that much. Or you can right click in the CPU window and do search for, we're going to do not current module because the current module is user32 DLL. And we're going to search for origin.exe. So in this case, we'll say all modules maybe for string reference. And it's going to take a bit of time if you do all modules, but if you're in the Origin.exe module, it's a bit faster. It's going to find all the things that look like a string, and you can see a bunch of them here. And then let's see if we can find something from this message. Depending on how it's formatted, it might be harder to find the string in memory. It might be constructed from things that don't look like strings that the debugger will not find. But usually you're going to find something. For example, in this case, I can find the download address for the exe. So you can see there's even like a HTML. Double click on it to see where that is pushed in memory. And you can see it's pushed here. and then it's calling a bunch of functions like create dialog, set window, and like, oh, so this is not a message box. This is a create dialog thing, right? A show window. So it's like a normal window. So they make their own dialogue. Those are the calls from Windows. Those are Windows calls to create a window. So those I can find back in the symbols and look for the same functions. So let's say show window. Um, you can see it's also imported here, and you can see you can go back in the CPU window for it, look for the reference and see where it's called. It will show you all the places where it's called. If it has multiple window, it might be harder to find, so the method using the string in this case might be better, right? But yeah, so here we can see this, and if we want to verify it, let me go back to the string I was at. Double click back here. You can always right click breakpoint, set a breakpoint to tell the program to stop here. I meant to just toggle breakpoint, it goes red. So that if you stop or restart the program with a restart arrow and you run it, it stops at the breakpoint. It says breakpoint where I set it address 66. 66, that's my breakpoint, and there's no window, so it's just before. And if you step into the code, which you can do here with like step over, you can go step by step, see what happens. And so it's gonna create the dialog internally, set some data, and then show window. Boom, the window shows up. So at that point, you're like, oh yeah, we're exactly at the space in the code where it's gonna do the bad thing. So exactly the same as for the DLL. We now want to know why is it showing this window. Like you could go there and just like knock the code or something so it doesn't show the window. But more interestingly, you want to know what is causing this window to show. So when I remove my breakpoint, it's also F2, and go back at the start of this function, so before the return of the other function, and just check like what's calling this. And I see three things. So one method for this, you can select all and just toggle breakpoints on all of them and just go to look at each of them, or sometimes you can just double click and kind of figure it out as well and see what happens in there. See if you get an idea when you see them, like it's getting some command line, some handle, it's creating a file, setting environment variables, create a thread. You can keep scrolling until you find something. We're gonna look at the other ones as well a little bit. You can see that different places in memory. This one tells you a lot less, as some handle, and then we're back to the same code because I skipped over a few functions. And similar here. And if you keep scrolling up to see what this function does and keep going to the calling function and so on, what I found for this one is that eventually it just verifies the DLL checksum to see if it has been modified or if it needs to modify to download a new one. So pretty simple. Another way you can find it is again going through the symbol, and you can look at something like verify, and you're like, win verify trust. Maybe that's the right function. You can look it up online, and you'll see that this is to verify if it trusts the signatures. You like check and see like what is it. In this case, it's not much. Could go for signature because usually those are called signatures, sig, or things like this. And eventually, you should be able to find something that way as well. In this case, I don't actually remember what it's called, but the Wintrust code is probably correct. So we could try see what happens there. For example, let's see what calls it. A bunch of stuff, a bunch of call on the jump. I was checking some certificate in Wintrust DLL. Okay, we don't want that. We want something higher than this. It's also in Wintrust DLL, so maybe that's not that useful. Or we can go back and see our other calls and actually do the breakpoint method. So let's try this. And the reason I'm showing you those different ways is so you can see there's different ways to get to the same result, and there's always going to be some ways that are faster than other ways. So I'm going to restart the program, run it, Shift F9. and we hit a breakpoint right now. There's no window. Let's just say to run again, see if that's the first breakpoint. Okay, we didn't hit any other breakpoint, and we get the window. And so we had F2B. That means the other breakpoints don't matter. So we're gonna just remove them. We just care about this one. Unload it again. Shift F9, breakpoint F at the F2B again, and see where we are. So we have a load library, which is interesting, right? It's probably loading one of the DLLs here. And let's see what else we have. The create file is back here. Still don't see any return from fset. From sleep. Oh, there is a message box here. Looking into the registry as well. Got cursor, so we're probably pretty early in the program now. What was doing with the clipboard. Fast here. So not that much interesting. If you hit Shift 8 or star, it will put you back at EIP or where the program is currently executing. So again, like I could skip some things here. I could go look into some of the function it's calling to just to see what happens here. I'm gonna do that really quick. So this is the show dialog, right? This is the one we don't want to call. And then it returns. And I go back. And then if we skip this, then we will load library, which is what we want. So one way could be to null that out or to jump over it. And you can see in the little arrows, there is one function here. It will jump over it depending on results. Let's see what this does. Nothing interesting. Look at the next one. Again, there's one that jumps here directly as well, which is this. Depending on the result of this call, probably does some kind of comparison, CMP. What that does, many things. We go back. There's one more. So this one jumps over everything. It could be interesting, and this is based on the result of that function. We could try this one with this jump. Sorry, this one above this jump. Just like last time, we can just spacebar and invert. So if that's jump if not equal, you can do jump if equal. And run the program, see what happens. So in this case, we are already too far in the program flow, so we're gonna have to actually restart the program before this jump. So I'm gonna put a breakpoint here, and in theory, we'll never hit the next one anyway. So just gonna restart the program. Run it. We're hitting our first breakpoint here. So again, I'm gonna change this instruction jump and run the program. And it works. So last time I looked at it, I found a function that does signature verification. I disabled that. This function probably calls it, right? If you dive into the function, you'll probably find it as well. But here you can see Origin's working now, so we're good. You don't even have to know what the function does. You just need to know where it's branching so that you can tell it not to do that, right? So just like for the DLL, I'm gonna just go to patches. It's gonna tell me again, you modified this. You might again just like export that, save just the change, or just do patch file, and then save origin.exe. So this time I didn't change anything. You can see module is origin.exe. Save that, close it, and now close the debugger. Wait to go. Then move your application, just call it like .ori or whatever. So you keep it, copy your modified version that loads the DLL, and then just test it. And now you get Origin working again. And we went through all the steps. So we modified the Origin DLL in order to remove the things that disable the menus and show the dialog, and the check that see if your user has to be migrated, so it will never do that again. And then we found that because we modify the DLL, Origin fails the check on cannot load, so we disable that check as well. And now everything works. And I don't know for how long it will work, but if it stops working, you know now how to modify the application further if necessary. And hopefully that was interesting and you learned something. Enjoy!